Welcome to another unit in the ISM Statistics 1 exercise set, this time with an exercise on correlation. Let's take a look at the exercise. Of 5 interviews, the time they spent on online TV series each week as well as their age is collected, resulting in the table below. Calculate Pearson's correlation coefficient. Okay, how do we go about this? First off, we take the original table, assign value of x and y to the two variables, which is more or less only to better refer to the values, not so much as x depends on y or y depends on x. So this could be arbitrarily assigned in this context. Then we add one additional row where we square all the x values. So we have 2 times 2 is 4, 0 to the power of 2 is 0, 12 to the power of 2 is 144, 24 to the power of 2 is 576, and 4 to the power of 2 is 16. Then we do the same thing for y. We have 32 to the power of 2, we have 23 to the power of 2, again 32 to the power of 2, 37 to the power of 2, and 19 to the power of 2. Finally, we have to multiply x and y, so we go 2 times 32, 0 times 23, 12 times 32, 24 times 37, and 4 times 19. However, those are not the numbers we are primarily interested in. First off, we are interested in summing up all the different variables leading to these values, but foremost, we need the averages for all the variables, so we divide the sums by 5 as we have 5 observations. So we get, for the time spent, an average of 8.4 hours. For the age, we get an average age of 28.6. For x squared, we get 148, and for y squared, we get 861.4. And finally, for x times y, we get an average of 282.4. Those are the values we're going to use to actually calculate the correlation coefficient, which is given via the following formula. On the upper part, we have the average of x times y, so the 282.4, minus average of x times average of y, so 8.4 times 28.6. All of this is divided by 2 roots, so the first square root contains the average of x to the power of 2, which is 148, minus the squared average of x, so 8.4 to the power of 2, and then times the second root, where we have y squared, the average, which here is 861.4, minus the average of y squared, so 28.6 to the power of 2. If we insert those values, will look like this, and if we input this expression into our calculators with one step in between, we get as a result 0.727. Okay, what does this 0.727 tell us? First off, this tells us there's a positive correlation, meaning older people spend more time, or people who spend more time usually are older. So we do not have causality, we only have correlation, so we only know that large values in one variable go hand in hand with large values in the other, while small values in one go hand in hand with small values in the other. This is one insight, and the second insight we can get from this value, well, as the correlation coefficient takes values between -1 and +1, particular positive correlations take values between 0 and 1. 0.7, that's a relatively high value. So we can see that there's a relatively strong relation between the time spent on series and the age. So it makes sense to assume that really people who are older spend more time watching series, or rather, well, as we do not have causality, there's really a significant correlation between both of those two variables. And well, those two insights then also conclude this exercise. So I hoped all of you enjoyed watching and, well, at least learned something new. So until next time, see you and goodbye.